Well, if we can do addition, then we can also do subtraction. And subtraction undoes additions. So subtraction of integers is what we want to look at. And there's a definition of subtraction that works nicely that really makes it the same as addition. And so if I have a number and I'm subtracting from it another number, I can think of this as moving in the opposite direction of addition. It's undoing, and so it moves in the opposite direction. And so I can rewrite this as an addition of the opposite. And so with the concept of integers, we no longer really have to think of addition and subtraction as two separate things. Right? They're reversible things. One undoes the work of the other. But we can think of them as one thing if we look at this as being the addition of the opposite. And again, we start seeing a pattern that we'll see that if the signs are different, the negative sign takes hold. So if I can look at any subtractions and pull this rule. So 6 minus 10 is the same as 6 plus the opposite of 10. And now if I use my addition rule, I take the absolute value of the bigger number, I subtract from it the absolute value of the smaller number, and I get 4. But for my answer, I want to grab this, absolute value of negative 10, negative in there. I want to grab the sign of my bigger absolute value. So this is this negative, that's negative 4. I could have negative 14 minus 19. So I'll rewrite this as an addition. Negative 14 plus the opposite of 19. Well, I have the same signs, so I add the absolute values. Negative 14 plus the absolute value of negative 19. So that gives me 14 plus 19. So that's equal to 33. But they were the same sign, so that's the sign of my answer, negative 33. Now I can get multiple subtractions, reading left from right. And subtractions are one of those odd things that the English versus the mathematics doesn't always have come out the same. So I definitely want to look at my order from left to right. And so this is saying I'm taking 5 away from 12, and then I'm going to take 7 away from the result of that. Well, I'll rewrite these as additions of the opposites. And now I can do additions in any order. And I'm actually going to look at doing these first because they have the same sign. So if I add the absolute values and keep the sign, so you get 12 plus negative 12. And here I have the addition of opposites, so I get 0. Can also do a longer chain. So I have 9 minus 6 minus negative 3 plus 8. Let me draw a line, separate these two problems. And so I'm going to do the same thing. I'm going to convert my subtractions into the additions of opposites. So this is equal to 9 plus the opposite of 6 plus the opposite of -3 plus 8. And so 9 plus -6, take the absolute values and subtract. That's 3, and I take the sign of the bigger number. So that's +3. I'll bring down the rest of my additions. 3 plus 3 is 6, and that's 14. This also applies to variables. Anything we do with a number, we can do with a variable. Remember, a variable is hiding the quantity. And so this is saying 3 times some quantity, I don't know what it is yet, minus another quantity. And if I say x equals 2 and y equals -6, well, I can bring, let me rewrite this down here. I can bring in my variables. Again, I'm going to use parentheses to keep track of things. You'll see how that comes useful here. When I do the subtraction, I need to keep track of the sign. And so 3 times 2 is 6. And I'm going to change this to adding. The opposite of -6 is 6. And so this is 12. Subtraction can also be used, and it's used a lot in measuring, to talk about the distance between two things on a scale. So right, Mount Everest, right, the highest point in the world is Mount Everest, which is 29,028 feet above sea level. So get down here to the sea. And there's the sea. And the distance from that is 29,028 feet. But if I go to the Dead Sea is actually below sea level. So I'll put this is the Dead Sea. This is Mount Everest. And it's 1,312 feet below sea level. Well, if sea level is my 0 point, I can think of this as a positive number, and this is a negative number. But the distance between two things is a subtraction, right? Well, I'm looking at 2 points, A and B, and I want to find the distance between them. If I subtract, I get the value in the middle, right? Think about, I move all the way out to B, but I take away the stuff from A, and I'm left with what's in the middle. Right? So if we visually think of this as a subtraction, let's look at this one. I have 2 points on the number line, A and B. And if I'm at B, I have all of this stuff here. But I just want the distance between the two of them. So I've got to take away from that all this stuff up to A. And so B minus A gives me the distance between the two of them. And the same thing happens here. I need to take one away from the other. So we'll turn this into a subtraction to find the distance between the two of them. So I'm up at Mount Everest, and I take away the depth to the Dead Sea. And we can think about it as moving in this case. I have to move all the way down to here, and then I have to move all the way down to here. But between any 2 points, we can use the difference as the distance. Well, this subtraction I can turn to addition of the opposites. And I'll write this using place value to help me do the calculation, because I've got some big numbers now. And so I'll let the place values help with my calculation. 8 plus 2, 0, carry my 1. 4, 3, 0, carry my 1. And I have a distance between the highest point in the world and the lowest point in the world of 30,000 feet. And so this is how we subtract integers.